Welcome back, everyone. I'm Akash Joshi. I'm the OR guru, and today we're going to be talking about the three types of linear programs, and I'm going to explain all of them to you. So, as you might know, the three types of linear programs are infeasible linear programs, unbounded linear programs, and finitely optimal linear programs. Okay, first let's talk about infeasible linear programs. So, here is a formulation I have given you of a linear programming model. We're minimizing this objective function right here. This constraint says that x1 plus x2 has to be greater than or equal to 8. This constraint says that x1 plus x2 has to be less than or equal to 2. And this constraint is a non-negativity constraint for the variables x1 and x2. Now, if you graph this and try the graphical approach for this linear program, you may notice something strange. So when you graph the two constraints, x1 plus x2, and you signal one of them to be greater than or equal to 8 and signal one of them to be less than or equal to 2, you are given these two regions right here, these two inequality regions. And if you notice, there is no point in between, there's no common point in these two regions that satisfies the formulation. For example, there is no x1 or x2 value that satisfies both of these constraints simultaneously, and thus the formulation thus the optimal solution does not exist. So no optimal solution in this formulation because the feasible region doesn't even exist in the first place. Okay, so the next type of linear program is the unbounded linear program. So so let's talk about the unbounded linear program first. Here is the formulation that I have given you. We're trying to maximize x1 plus x2, and here are two constraints, and they're non-negativity constraints here. So if you graph this, you get something that looks like this. Sorry for all the color coding, it may get kind of confusing. Just know that this constraint's feasible region is yellow, and this constraint's feasible region is green, and the whole formulation's feasible region is red. So right here, this line right here is this constraint right here, and this line over here is this constraint over here. And if you notice something, that they're both greater than or equal to 7, so that means the feasible region is going to be above these two equations or inequalities, and the feasible region is right here. So, okay, so why is this unbounded? Can't we get an optimal solution here? Yes, we can get an optimal solution, but the thing is, we can always get an optimal solution that's better. For example, we are maximizing x1 plus x2, so we'll always be going up to infinity no matter what. We're going to keep increasing x1, which is our x-axis, and we're going to keep increasing x2, which is our y-axis. So we're just going to keep going on until infinity, and therefore there are multiple optimal solutions. There are infinitely many optimal solutions that are better than each other. Okay, so that is an unbounded linear program. And remember, this is not to be confused with an unbounded feasible region. So let me talk about an unbounded feasible region. So I've just copied the formulation from above, but I've changed one thing. Instead of maximizing the objective function, we are going to minimize the objective function. Now, there's still an unbounded feasible region. All of these solutions still work. They're still considered optimal solutions. However, there's only one true optimal solution because that will be the most optimal since we are minimizing. So instead of going on until infinity, we are minimizing x1 plus x2. So we're going to go the other direction, and we are bound by these two constraints. So the intersection of these constraints will be our optimal solution. And technically, this having an unbounded feasible region does not mean that your linear program is unbounded. Technically, this is finitely optimal, even though it has an unbounded feasible region. So really, this part should belong on the next slide, where I talk about a finitely optimal linear program. Now, the finitely optimal linear program is what most operations research analysts are looking for when they formulate a linear programming model. Let me talk about this. Say we're maximizing an objective function. This type of linear program is easier to visualize graphically rather than mathematically, so let me just show it to you. These are our constraints, these three lines here, and we are trying to maximize the value of x1, which is our x-axis, and x2, which is our y-axis. And the way we'd do that is we would get this solution right here, this little dot here, this intersection between these two constraints. And if you notice, there is a feasible region. So this program is not infeasible, and the feasible region is not unbounded because it's limited within these constraints. So yeah, that means that it's finitely optimal and there's one true optimal solution. There are many feasible solutions because all of these in the feasible region, all of these points in the feasible region could work, but technically there's only one true optimal solution, and that is this point right here. Okay, thank you for watching. I hope you learned the three types of linear programs. I'm Akash Joshi. Thank you for watching. Goodbye.